Hello to everyone and good morning, especially to our friends in California. We are actually we're planning this kind of master classes so that we are in prime time in at the West Coast. So before lunch on a Friday. So happy Friday to everybody. Yeah, this time we are doing something very different than we did that before. We always were focusing when we were giving master classes on technical items, and that for us is the first time where we are going a little bit away from a technical standpoint, more towards product management, program management, and what actually EMC has impact on those kind of areas when you are developing a product. So title of this webinar is The Real Cost of EMC, Hidden Expenses that are eating your product margins. And yeah, I'm very curious also to hear later on from you in the chat if you liked it, if we should go more with those kind of details, because we want to give you a full and wide overview when it comes to EMC and EMI. So first of all, let us introduce, for those who haven't yet participate in a masterclass with us. My co-host and my good friend Ignacio is today with me. Ignacio is our master of EMC at Denpaflux, so he's running the whole operations with his team of really brilliant EMC experts, which are helping our customers to get to a robust design. He knows a lot about EMC, what I do not know, to be fair. I'm more coming from a product management standpoint. Yeah, and I'm very happy to have you in my back, Ignacio.
Thank you very much, Marc. It's a pleasure to be here with you. So welcome, everybody. It's a pleasure to have you all, and good morning. So please, if you have any questions, so write them in the Q&A session at the end of the presentations. We will go through them. We will answer any question related to the presentations, to Denpaflux, to any EMC-related question. So please don't be shy.
All right, very good. Also some words about myself. My name is Marc. I'm the commercial director here at Denpaflux, taking care of the go-to-market operations, what is it called? So doing marketing and sales. Actually, I'm doing that for a long time, almost 17, 18 years. And I was doing also selling electronic parts, like control units and stuff like this in the automotive area. And what was surprising to me is how much actually EMC, EMI is also affecting us on the commercial side. And I also was responsible for some product activities in those kind of things. And that made me wonder that we really need to reach out to you guys as well and let you know a little bit from the other side of the coin, right? When it comes to the commercial. And I want to start with a little bit of a story which may sound familiar to some of you. So when I come in as a sales guy and I need to communicate to the customer something about it is delayed, your product is delayed, it's getting more expensive, I wasn't touching it from the beginning that this has done something to do with EMC and EMI. But now, as I'm working now longer for Denpaflux, I understand that how that actually is working. And it's kind of a domino effect, right? So we had that in that regards that we had to delay projects. We had to say to the customer, sorry, the BOM cost is increasing because we had to add the material. And that all goes to the front when an EMC test is not going well, and you are under such a pressure as a company to bring out the product to the market, that engineering starts grinding on that, doing the troubleshooting, and then it goes all the way down through purchasing to buy certain materials to contain the EMC, to contain those issues by using ferrite beads, EMC foil, EMC filters, and stuff like that. And that goes all the chain down, right? Because then you have that with the manufacturing cost, logistics, product management, controlling, and everybody's on board. Not also to mention like quality, which has also an impact on it, because more material means more like issues or potential issues which you can create. And that is actually where you come from a 5,000 standpoint where you are retesting to easily 100,000 in a cost impact. I hope that rings a bell for you all. And if we are looking at that as a little bit like an iceberg model, I really like that in so many things. Like for us, when we are trying to convince a customer to go with us and we are doing our calculations, we almost are on the visible line of cost, what we are calculating in our product inside, right? So for us, visible are the cost for the lab and for the engineering hours. We may also a little bit under the surface can do some provisions that we're saying, yeah, I know I need to go for a second loop. I need to do a little bit of provisions. I may need to go for troubleshooting. But then the layer, which is really, really hidden, which is really down below in the ocean of the iceberg, this is really, which is then exploding your cost and eating up your margins, that you are starting with updating your BOM and having more material, the complexity you have to handle and all this stuff. So that being said, I would like to make a short poll to you to see how you feel about what are challenges when it comes to EMC M&I, and also a little bit towards this discussion what we have margin-based. So Ignacio, feel free to start our little poll. You see the question, what is your biggest EMC challenge? And it's multiple choice. You can say whatever you want. Let's just go and run through this a little bit. Late stage EMC issues, recurring costly fixes. We know that. We will talk about this a little bit later, what we understand it as hot patching. Better being safe with over-engineering, unexpected EMC-related cost because we were not able to consider EMC at the beginning, project delays, quality issues, market opportunities we have missed because we have put so much efforts into the product and we made it maybe safe to go, but then another competitor kicked us out. And yeah, customer relationship strain due to the product quality because they don't trust us anymore. So feel free to answer. We give it about 30 seconds and then I'm very curious to have a look at that.
Yeah, I'm very curious also. I see that there's still a few people to answer. Please answer it because we're going to share it in a while. And I think that it's very interesting to learn from each other. So please.
And also, don't worry, that is anonymous. Nobody will see that you have answered those things. So we are all good here. And we are just friends around.
Yeah, perfect. I'll say that. A few seconds more and then.
Let's give it a countdown. 5,
4,
3, 2,
1. Let's go. So here it's over. So do you want to see the results or do you want to wait for the surprise?
No, let's see. What do you expect Ignacio to see? Okay. Late stage fixes request costly fixes is costly. Yeah. That is the highest priority. Over-engineering EMC protection. Yeah, heard about that too. And but what is project delays due to EMC problems? All right, guys. What is the last one? Market opportunity missed due to EMC delays. Okay, interesting. I wasn't expecting that nobody was going with this one. Customer relationships strained due to poor product quality. I see you're putting a lot of efforts all in for keeping your customers happy. Congratulations. All right, good. Thank you for giving your honest answers to this one. Actually, I can tell you we will focus on this one, on this late stage EMC fixing, and also about the over-engineering EMC protection. This is where we today will look a little bit into it. A short header from my side. That presentation is filled with a lot of information. And I know we have to keep presentation short, but also we want to give you something on the hand, at your hand, that you can pull up and you can look into it again. So it's a little bit like also a documentary presentation, which is helping you later to figure out things and stuff like that. Yeah, talking about hot patching pitfall. Hot patching, I don't know if anyone else is using it, but since I'm working at Denpaflux, I'm using this because I was talking to some customers, and Ignacio, I bet you too, where they were saying, help, please help. I'm coming back from EMC laboratory with my test, and I have to hit my target with timing, and I cannot do it. So
Yes.
Ignacio, you know the story. It's the story of our lives, right?
Yeah, been there, done that. A lot of tears, a lot of suffering, and customers looking for the silver bullet.
Yeah, absolutely. And that is actually what is happening. So you're coming back, you are having some solutions to bring down the radiation by using certain materials like ferrite beads and other stuff what is around there. And you are sorry if I say that this way, but you're throwing it at your product to make it safe, right? And so that you can keep the time. But sometimes that is also somehow what is being expected. It is an proven technology to use certain materials to bring down your issues with EMC, EMI, and to make it work. So some of our customers or some of people we have worked with and collaborated with, they were saying it is an understanding for me that I need to go this way. But once you walk down this road, it's a question: how do you see those things in your product, and how you can identify that? Well, you could go and do a BOM review, by example, where you look into it and see what are the materials and what kind of purpose do they have. Are they for the performance? Are they for the security of the product? Or are they for EMC-EMI? And once you have identified those, you're going down and you can look into it. Can I delete them? Can I redo some engineering work here, design changes, so that I can take this out of my BOM? Where to look? Absolutely. BOM is a starting point, but it drills further down. It drills into the manufacturing, as we were talking, increased cycle times. Just to give you an idea, putting on a foil is not that easy. When it comes to an EMC foil, it needs to be a proper and smooth process, and you have to ensure that it's really stick to the product correctly. Or ferrite beads, if you have to wrap it around the wiring harness, it's a little bit tricky. Most companies are doing it when they have small batches, either are purchasing it with the ferrite bead directly from the supply base, or they do it as a manual process. As we also talked about quality, more parts means more options to fail, especially when those product steps will be done manually. And we don't need to talk about logistics cost. I have to build up my pipeline. If I have bigger operations to run, I have to store the material, and I have to do householding with the material. What does that actually mean for your business? Sometimes, as I said, I'm coming from automotive. It is a very tough business where you are going with a cost plus statement. And if you are saying, I settle for a price, the OEM signs with you the contract, and then you're done, you're sealed, and you have to bring the price to it. Either you have to eat up the cost on yourself, then you have what we call here margin erosion, that you have to absorb it on your own, because also the customer may turn back to you and say, you know what, I awarded you for the program. You had enough time to contain this problem, and you didn't. Therefore, if you have to do extra activities, you have to put it on your own card. And it's also being a trust issue when you're coming back to the customer and say, hey, the BOM is changing, we have extra processes in that might also end up in increased margin discussion with the customer, where they're saying, why do I have to do that? I thought you have that under control and you don't want to go there. The other way around is late, that you can do it also early somehow. That you're saying, okay, I don't want to burn my fingers. A lot of teams, what we also experienced is, a lot of teams actually, they burn their finger once and then they were saying, now I need to play it safe. And I play it so safe that I over-engineer it and I do it like the maximum safeguarding strategy from EMC. I apply that on every product I going to produce. Even it's the powerful version of my product or the small version of my product. And one size fits all always sounds nice because we're saying we have less complexity and all this stuff, but also you are all inheriting then yourself cost into your product, which is not necessary. So also here, it is almost the same strategy a little bit with the over-engineering. How do you know that? In those kind of, you need to do a BOM analysis too. And you may need to learn, by example, you could do a benchmark from a different one and understand how is the cost margin or how is the ratio for EMC activities in a benchmark product if you are taking that apart. And then you understand where that is coming from. A very interesting rule is also that a lot of companies where we have been in contact, that they were saying, we have our principles in place and we don't touch them. We don't touch them because they are working for us, and that's why we want to go this way down. But you have to also incorporate from time to time that there are changes in materials and in procedures. Like the introduction into the industry of SICK and GAN was something where a lot of engineers were starting to update those kind of guidelines or principles, design principles. And it comes a little bit different. You have to look here also very much into yourself, into the engineering, into the development, and say, how much have I done? Where am I with my documentation? How do I treat best practice in my company? Because that is like the starting point where it's like running away for you. Primary business impact is here a little bit different because you are able to make your product and it is working and everything is fine, but it may have a little bit of an impact of your market position. You are not right there that you are the best leader in cost competitiveness, perhaps, because you have this extra add-on in your product calculation. And you might not be so agile to do new business opportunities or to look for new implementation. If you need to upgrade your product for you, if you always are following your design principles and guidelines, and now you need to step up the product with a new feature. So what can you do? There are two ways what you can do. One way is you can do corrective actions, as we know that from AD. If I see a problem, I correct it, and I take care of that, and I try to do that. But that is only for a short time. And what we are looking more when we are talking about ADs, that we have a permanent or a predictive, preventive action here, right? But let's focus on the corrective action, because we want also to give you something on the hand what you can use with your day-to-day business, and what you need to, where you can say, oh, that product is in the field, what should I do with that? And it seems to be simple and easy. It's like identify, develop, evaluate, and execute and monitor, which we all know is like a standardized way to do it. But also there, I want to emphasize on a pitfall there. We all have like design change processes, which might be very like overburdened. We have to develop an idea, then we have to estimate or assess that, and then it comes to the evaluation, and then you're already losing a lot of time. So what we want to give you actually as managers here in the room and decision makers, a kind of what we are calling the quick optimization calculator. And I just want to say that that is our little giveaway to you after the show. And this is really a one-pager where you can do a quick analysis of your current BOM and like figuring out if it really makes sense to think about it, and to think about that you can go there and get the cost really done. So here we have an example where we're saying we have an industrial controller. It's still running for 5 years. We are producing 25,000 units per year. And we decided then to show you what is going on with the BOM. You can then enter data about manufacturing analysis. You can do then the revalidation, what you have to do, and the recertification and the testing also gets in. And then you have a quick estimation. Really, in 10 minutes, you can calculate that. To say, does it make sense to put my team on that thing to really spend 20 hours or 30 hours to go down the road and develop something? It is really easy that you get two answers. You see how much is your one-time cost, because you have to calculate in that you have to engineer it, you have to manage it, and you have to later adjust your manufacturing process as well. And when is the break-even point, right? So they were saying the saving is here 32,000 euros. We have to spend 40,000 euros. So after 1.2 years, there's a break-even point, which is 24% of your residual lifetime. It just should give you enough that you can go with a confident feeling into this and say, I want to go down the road and understand what is going on with my product here. So
hey, Marc,
that is, yeah.
Before you go back to the presentation, here we have Carlos asking if you don't mind zooming it a little bit. So if you have any questions, please don't hesitate to write. Also, I want to mention, as Marc said, you will get this file after the presentation as a giveaway for being here. So you will be able to play around and to introduce your calculations, your project, and to see how, or to have an estimation on how much money, or what is the real cost of EMC. So no problem at all, because you will get this afterwards.
Absolutely. And also, as we are putting our email address here into the presentation, feel free to have a short chat with us. I'm always happy to connect with someone for 5 or 10 minutes over a digital coffee and looking into this and maybe giving a little bit of an advice. And I tell you, that one is for free. Okay. Was there something, Ignacio, regarding this one as a question, or should we jump into it for a second as we're here at that point, or later on?
I think that we can always come back later if there are specific questions about it.
All right, good. Then we will continue with the slideshow. So, and I don't want to run through this and tell you what is exactly being said here. In here, you can read that down, but it's actually identifying that you really go into the BOM, that you're going into your manufacturing processes, collecting those data, that you develop an optimization plan. This is where you, as engineers, are being asked to have a review, to see what are the ideas, to make it a design change bundle, which is the best what you can do. Bring everything together and say, okay, we can do summer shutdown time, and then we are putting that in. Needs, of course, evaluated and then executed and monitored. The monitoring, I just want to say that it's very, very important that you get a good feeling about it. And what you also get as a payoff from that is like the continuous improvement, what you really can implement then also to other projects. Coming now to the preventive actions, which are way more interesting, I believe, when you're setting it up right from the bat. You have less to worry about it. You can sleep better, so to say, because you have everything set up for success right from the beginning. And it's a little bit different. It's not like steps you're going, it's more like areas you need to look into it. You have your early design phase where you have to really, you should be thorough with your requirement definition and with how you want to set up the project in the development process. I think one point which is very interesting I want to lay out is besides the testing strategy, where we also seeing a lot of customers are saying, I set everything up, and then I was going to the test facility, but I was going with the totally wrong testing. Ignacio, maybe you can elaborate a little bit on that.
Yeah, sure. Related to the testing process.
Yeah.
Yes. So the classic. So there are different approaches. The first one, which is unfortunately the most popular, is to visit the EMC chamber for the first time when the system is completely ready. So that is manufactured, assembled, and ready for production. And then people think, oh, now is the moment to visit the EMC lab. And unfortunately, there are normally a lot of surprises. So a second approach is to perform some pre-compliance testing. So that means that you don't need an official laboratory. That means that you don't need to go to a notified body that is going to give you an official report, but that they will measure some critical parts of the system to the risk. And sooner you do it, you will have better insights of the potential problems of your system. So it's you don't need to spend the whole budget of compliance on that phase, and at the same time you will get a very accurate results.
All right, thank you for pointing that out. One point I would like to have a little bit longer on that is like timeline management. Like everybody would now say, duh, timeline management is important. We all know that as earlier as we begin, as better we can be, but we know all how it works out, right? The product manager is coming around, or the project manager is saying, this is a timeline and you have to run now. And you start to run. And you may not have the time to incorporate that. So I get that. So also quick tip here is, how can you ensure that EMC-EMI is taken care of while you are going this way? Look for an EMC buddy, by example. Make a choice of your consultation or external services before you're starting with the project, so that they are already incorporated and that they can jump and help you when you need them. Yeah, and not that you need to start to look for them when you are hitting the rock bottom when it comes to EMC-EMI. Then it's double trouble for you, right? You have to look for someone, you have to onboard them, and you have to explain them the problem, and that is already losing some time. So some preventive actions already to bring them into your timeline. Not saying that everything needs to be set in stone, but that you are having a good safety net for yourself. Cost control is for me also, especially as I said, with the background of commercial and price sensitivity, that you understand where the costs are coming from so that you can quickly action about it. I saw bombs in my life which are not really laying that out, what is the root cause for that being in the bomb. Is it for the performance, as I said, or is it for something else? And knowledge management, we see that this is something how you pass on knowledge. We are creating more and more documents, but it is very hard to keep up with those. And working on a lean, easy to access knowledge database is really key also when it comes to something like EMC-EMI or in general. So when you are using those kind of topics in preventive actions, it will help you to identify already up the stream during the development processes your EMC-EMI requirements to control and check always consistently where you want to go and where you need to go, so that at the end you're coming to a point where you are standing in front of the EMC lab and you're going in there with a lot of confidence and say, I got this. And that will bring down your cost. Yeah, and actually we're a little bit over time as promised, 30 minutes for the presentation, but just only to wrap that up, what did we learn today? so what we were looking at actually at, because I think also for a lot of you guys, that is something you already hear like certain days when you're coming together with your commercial partners in the job or with the product management team. But we were talking about visible cost, invisible cost. We were talking about reactive and proactive approaches, and how you can get rid from this firefighting into a more systematic solution. Of course, there is so much more to discover, and it's always dependent on that. But we really wanted to give you something where you can now take actions with, and you can explore your opportunities here. So the takeaways are: costs are not only in engineering when it comes to EMC EMI, they are traveling all the way to the product and even further if you want or not. And something what I believe is also known, it's over-engineering and under-engineering is hurting your competitiveness. I think this is going without saying as well, that as earlier you are doing preventive actions, it's getting better. The question now, like here in the right corner, can we afford to change our approach to EMC? The real question is really, can we afford not to? Because as also the title is saying, from challenge to advantage, it really helps you. Being earlier there makes confidence to your customers to get things the right way done, and shows them that you are in a very mature level. So that is how you can take care of that. Ignacio will also, why we are talking about this? Well, we are actually in the preventive corner of doing EMC EMI, and that's for the moment what we can tell you in general about the topic. But also maybe Ignacio can tell a little bit and give a little glimpse into our product. We are taking care of EMC EMI, how we are showing that to our customer, and how we are actually a part of the solution, bringing down the cost, and even are making that leaner for the product for the engineering cost, but as well for the production cost.
Yes.
Thank you all.
Perfect. Great. Thank you. Thank you for the nice presentation, Marc, and thank you for the overview on the whole process. I'm pretty sure that most of our attendees will relate to what you have described, and they are thinking, oh yeah, I've been there. So I want to show you now how we work with customers and how we deal with EMC. So as Marc mentioned, we are in the preventive phase. So that means that we want really to help people to work on EMC at early stages, so that they are not in the high panic area, but really to move that panic to the more relaxed area timing of the project. So where you have time and budget and enough room for modifications and to tackle EMC, so that in the end you increase the chances to go to the EMC chamber for the first time and never go back again. So I'm going to share my screen. Let me know if you see it. Give me 1 second. Can you see my screen?
Yes, it works.
Perfect. So if you go to denpaflux.com, so this is our website. Here you can you will have an insight of everything what we're doing. So the EMC Hub where our masterclass of today will be recorded and will be available for download. And here, so you will have access to your account. So today you can create an account and register, and you will have access to some demo projects. So once you create an account, what you will have is access to our Denpaflux platform. So this is the main side, and here you will have an overview of the projects that are your projects. So some of them are demo projects. So these are by default the process. You can see that you can start playing around, and here you can upload the projects that you or your engineering team are working in. Also, you can manage, so it's not only the platform can be used by different team members. So here, so you can add more than one person of your team. So if you have a schematic designers, hardware designers, or if there are more people, more than one person working on a project, and here you will be able to add more than one project. So how do we do is that we work on EMC at the design stage. That means that we make design reviews, we make EMC assessment at the design stage. So that means that we need to check your files, or we check your files while you are designing, not afterwards, no when you have manufactured the files, no when you have already sent everything to production, really when you are designing. So when you are designing, you have a schematic file, you have maybe a 3D model, you have ODB++, which is a manufacturing file similar to Gerber. And we take all of this and we make EMC assessments. So what we do is that we check what can be wrong, what can be improved, what is good, so that on each stage you have a good overview on the things that are going good, things that can go better, and things that are really a non-go, like things that are aspects of your design that really need to be checked, because otherwise you will have high chances of failing EMC problems. So here, for example, we have an EMC review of a schematics. So we talk about connectors, how you need to protect them, how do you need to assign the pinnings, because they can provoke EMC problems due to the grounding. We check filters, input protections, polarity reversals to be sure that your system is prepared for the industrial environments. So we know that it's not enough for a system to work in a laboratory environment. We know that systems need to work on real environments, and that can be industrial, that can be household, and there's a lot of noise, and there's a lot of possible interferences. So we check that you have filters, that the filters you have designed are properly designed, that if there are components to add. So that's on the schematic side. Also, so what we check, so of course, is the PCB level, because we know that it's one of the key components of electronic design. So here, we go through problems or challenges related to stack up, which is one of the most critical points for EMC, because it's linked to conducted radiated emissions. We check different configurations, component arrangement, zoning, analog, digital. So anything that can provoke EMC problems at the certification phase. So let me show you, for example, another project. So the idea is, this one better. So is that we know that getting EMC right first time is hard. So that's why we know that we need to work little by little, because there are changes that take a lot of time to implement. So for example, changing the stack up or changing the zoning of a PCB takes a lot of time. And as soon as you detect that there can be a problem, you will have much more capacity and much more time to make modifications. So that's why how are we working is, so we want, or what? So we receive a specific file, so one of the designs. And then what we do is that we highlight the most important problems, the most important things. So for example, here, this board, the stack up is wrong. It's going to have EMC problems because it doesn't have any ground layers, and we know that making that change is very difficult. So that's why we highlight this problem as one of the most important ones, and a few others that can be important, but that you can also implement. And then the idea is that you make these changes, and then you upload very fast a second iteration. So then that we can check them, we can check again the next most important problems, so that you iterate, that you to upload consecutive iterations in a very short time while focusing on the most important topics, so that at the end of the process, so you have a green light, so that the risk of having EMC problems is very low. What else I can show here? So for example, let me show a complex PCB, like radio frequency PCB. So we're working with different products, radio frequency, IoT, power. So here, so this is our interactive viewer. Where areas where you might have some problems or some areas to check to your CAD tool. And this is a very short glimpse on the platform. And then I think that now, Marc, so the stage is yours back again, and then we can go back to the questions. We can start with the Q&A.
Yes, we can. So again, thank you all. We are going now through the Q&A, and I would leave it to you actually, Ignacio, a little bit.
Yes.
I take the second one. You can have the first one. I take the second one.
Perfect.
And then we will look into it.
Okay, I'm seeing more questions. Okay, so I will start with the first one. I'm not completely sure if it's a question, but what I'm seeing is faster the circuit, the more chances of emission. What is opening this, especially in high-speed digital designs? Yes, indeed. That's one of the most common challenges today, is that not only frequencies are increasing, but also switching times, rise time, low time, and that is a huge challenge for EMC, because frequencies and bandwidth are getting busy out there. And indeed, that's one of the things we check. So we check the frequency, if there are radio frequency modules, if there are memories, if there are microcontrollers, and we check also for, so not only for frequencies, but also with what are the switching speed. So that's one of the biggest problems or biggest challenges, because it's never stopping. So frequencies are not going down. So that's what we need to be ready for the technologies of the next 5-10 years, and to be ready to pass EMC, even if the digital designs are getting more and more complex. And the very last question, what kind of security encryption? So Diego, if I understand well the question, are you asking for the security while receiving the files and while we upload the files? So so we have two parts. It's one part is that we completely understand that the files that you upload are your design files. So those are the most sensitive IP and the most sensitive data that you have in your product. So that's why we take care of all the encryption end to end. Okay, I see here that you are mentioning design data. One thing related to design data, one of the format files, or the file format that we usually work with, is ODB++, even if we accept any other kind of CAD data. And the main reason is because it's a good middle ground between PCB manufacturing data, like Gerber files, that are just a snapshot of the PCB, so it's very hard to extract EMC insight from them, and sharing the native CAD data, like the Altium PCB file or the KiCad PCB file. But of course, you can also do it. So in our case, so we store the data. So it's everything in Europe to be compliant, also with the GDPR rules. So we really take care of protecting and encrypting the data. So we know that it's the most sensitive data between us and our customers.
And also, for those who are curious to work with us, we are happy to discuss those kind of things more in detail. There is also like we are signing an NDA with our customers. We have also a self-signed NDA on our website, which you can download and can read through this. We understand this is your highest value you have in a company and you want to protect it. And we want that too. As I also said, Ignacio and myself are happy to have a coffee if you have questions or you want to drill down on a certain stuff to get a little like a brainstorming on it. Otherwise, it was a great pleasure to have you today. Happy Friday, everybody. Have a great weekend and hope to see you soon in one of our masterclasses. A heads up, what we are going to plan is one masterclass about PCB design, not the PCBA design, the PCB design, how to make it efficient and to ensure EMC. That will be interesting because I think there are two master disciplines being asked. How can I be cost efficient and how can I be safe? And watch out for that. It will take a little bit, maybe 1 or 2 months, but it will come up.
Thank you very much, Marc. Thank you very much, everybody, for being here. That's been a pleasure.